Welcome our participants to our online course on groundwater quality, module 3, where we talk about the relationship between climate change and the groundwater quality. We are now on the objective number 3, where we talk about the relationship between climate change and transport contaminant in explaining groundwater quality. My name is Kanyerere from the University of Western Cape in South Africa, and I will present this objective. Now, this slide here introduces us to the concept of transport contaminant, or solute transport, or contaminant transport. We are talking about the movement of contaminant in the groundwater system, which depends on the hydrogeology of the system we are working on. We are talking about the contaminants tend to move more rapidly or more quickly in a more permeable units. So the geological environment which has more fractures, more porous, more pores, a groundwater tend to flow easily in that environment, and therefore the contaminants also tend to move quicker and easily in that environment. So less time to react with the solid materials, and also more time to travel in fractures, in faults, and fissures and cracks. So the geology of the area explains whether the contaminant will be transported quickly or slowly. When you look at the climate change variable, we are focusing on rainwater and temperature. And we tend to state here that the rainwater dilutes the contaminants. So rainwater has a diluting effect. More rainfall, it means the contaminants are becoming more diluted in the system. Rainwater speed up or can slow down the movement of contaminants in the aquifer system. The aquifer materials themselves, the unit that contains clay, so the clay materials generally slower down the contaminants, or absorb or attract the contaminants in the system. But the sandy materials, the gravel materials, they are more porous, and therefore the contaminants travel faster in that environment compared to the clay environment. So the movement of contaminants in the aquifer system, it depends on the geology, and depends on the climate change, it depends on the aquifer. This session would want to emphasize the importance of climate in moving the contaminants in aquifer environment. We continue to state in this slide that the reactions that affect transport in groundwater, they are several. And some of them, they are adsorption and then absorption, then ion exchange and mineral precipitation and biodegradation. There are several of them. And we tend to remember that aqueous geochemistry will influence these reactions, whether they can occur or not occur, or at what rates they do occur. But we know that the presence of water will facilitate the reaction of these reactions in the aquifer system. So some of these reactions, they can be reversed, some cannot be reversed, and some they take a change of the geochemical conditions, which might release contaminants that previously remained in the system. On this slide here, we would want to present that certain contaminants, they are conservative, or certain movements, they are more conservative and others are not. So conservative contaminants, they are transported at a rate of water flow. So they tend to follow the behavior of water movement. And most solutes behave non-conservatively, and the reactions slow down this movement. Now, climate change through the changing rainfall and temperature, they are fundamental, they are critical to controlling the groundwater flow and the transport of the contaminants. What we are stating here is that the climate change through the changing rainfall, they tend to dilute and move faster the groundwater, the movement of contaminants in groundwater, and the transboundary is not an exception in this scenario. So it is the rainfall which is the variable of climate change which dilutes the contaminants and which facilitate or slow the movement of contaminants in aquifer system, and therefore we can use a rainfall to explain the quality of groundwater resource. This slide here, it shows how we test the movement of contaminants in the aquifer system. So the graph to your left hand side, it is showing where we put the tracer solution that contains a sodium bromide and a nitric acid as a solute, and then we pump that into groundwater, or we flush that into groundwater, and then we see to collect sample to the next sample to see how far it will move to that. Let me go to the next. Now the graph to your right hand side is only there to sample the water to see how much has come into the aquifer. So it's an observation well and where we collect well. Let me move on the next one. Yeah, this slide here, it shows how quick the contaminants move from the injection borehole to the monitoring borehole. So we put salt, we put contaminants in the borehole, in the injection borehole, and then we wait at the time where it will appear in the observation borehole. It can be mat level samplers or single level samplers, but the message here, we are observing the groundwater flow direction, and then we know that the contaminants will move towards where the groundwater is flowing, and then we time up, we check the time to see how quick does the contaminants move in the surface from the injection borehole to the sampling borehole. This is one way of checking the speed of contaminants in a water, in a groundwater resource. But what we are saying here, that it explains the quality of groundwater resource depending on the contaminants that are in the system. This slide here, it shows the movement of plumes, the movement of the contaminants, the pollutants are in the groundwater system, and therefore at the spill site where the contaminants are entering, it moves towards the flow direction. So groundwater flow direction is very important, and therefore the rainfall, which is driving the flow direction, and they also explain where the contaminants will be flowing in the subsurface. So the whole slide here, it shows that it is important to understand the flow direction of groundwater resource, because then it will tell us the direction of the contaminants moving in the system. This slide here, it shows the different sources that comes into the water surfaces, and then that water becomes a point recharge, and therefore the contaminants goes into the subsurface. So it's a slide like the area one where it shows the sources of contaminants and how groundwater receives the pollutants or the contaminants from the surface water, and therefore we need to understand the flow direction where this groundwater will move to. So if we want to protect the groundwater, we need to understand the contaminants that moves in the groundwater and the flow direction of the groundwater resource system itself. This slide here, it shows the rainfall, a relationship between the rainfall and the contaminants, or the movement of contaminants, that it depends on the flow direction, it depends on the recharge rate, and the recharge rate comes from the rainfall, and depends on the flow rate and the dispersion of the contaminants and the aquifer material, characteristics of the aquifer material, and again the chemical properties of the contaminants and the geochemistry of the aquifer, and all this combined, the bigger message that the water facilitate the movement of contaminants in the aquifer system. Therefore, more water in the system, a quicker the movement of the contaminants, or faster the movement of the contaminants, and less water, it means less movement of contaminants and slow movement of contaminant, and the driving force is the materials. This slide here, it shows again the capture zone, the area which will capture the water to go into the subsurface. So the surface area at the water table where water entering the groundwater system eventually flows to the borehole, and that need to protect that area from the contamination. Rainwater facilitates the movement of contaminants in the aquifer system, and more water means the faster movement of contaminants, and contaminants are transported at the rate of the water flow, and rainfall is the driving force to the contaminants to move. And therefore flow models and transport models, they need to, combined with climate models, need to be understood better in explaining the movement of the contaminants. Thank you very much for listening to this introduction to relationship between climate change and the transport contaminant.